Hello and welcome back to Atomic Math. Today we're going to talk about forces. And specifically we're going to look at three forces, but before we get into that, let's talk about what a force actually is. A force is a vector quantity because it has both magnitude and direction. And a force is also something that will cause an object with mass to change its velocity. And of course we all know the equation, force equals mass times acceleration. So let's take a look at the first force that we're going to talk about today. And that is weight, or gravitational force. This is what we feel on the surface of the Earth every day. To calculate that, we just do minus mg. Now it's minus because gravity's pulling down, and we're using the letter g instead of a because it's specifically identifying gravity. Next, we're going to look at the normal force. Now, the normal force is a force that is perpendicular to the surface. When an object is placed on a surface, it pushes back. We calculate that by mg cos theta. And the cos theta is there in case we're not on a horizontal surface. So, for example, if we had a table and we placed a box on it, our gravitational force is going to pull straight down. That's our minus mg. And in this case, our normal force is going to point straight up, and it's going to be positive mg. So it is equal and opposite to the gravitational force. In this case, we would say that our theta is 0 and cos of 0 is 1, so that's why that just disappears. But we have a different situation when we have a slope. If we had a box on this slope, our gravitational force is still pulling down, but our normal force is perpendicular to the surface. So you can see that it's not an opposite amount. We would have to find the component of the gravitational vector that is perpendicular with the surface in order to figure out how much our normal force would be. And that's where that cos theta comes in. We multiply it by cos theta and it finds that component for us. Okay, let's take a look at our next one, which is friction. So friction, like the normal force, is exerted by a surface, but unlike the normal force, friction is always parallel to the surface. And there are two types of friction. So the first one we have is kinetic friction, and it opposes motion. So this is the friction that occurs when something is already moving. The second one is static friction, and it prevents motion. So this is the friction that kind of keeps something in one place. So to calculate the static friction, we say that it is less than or equal to the coefficient of static friction times the normal force. And we say less than or equal to because the static frictional force is sort of a responding force. It only pushes back as much as it has to keep the motion from happening. It doesn't push any harder than that, so that's why it's less than or equal to. Now, of course, once you go past that equal to, then you're going to start moving, and that's when your kinetic frictional force kicks in. And this we calculate by using the kinetic coefficient of friction multiplied by the normal force. Now, in general, the kinetic coefficient is going to be less than the static coefficient. And I'm sure we're all familiar with that situation of having to maybe slide a really heavy box across the floor. It always takes a little bit more effort to get it moving. And then once it's moving, usually it's a little bit easier. So that is the difference between your kinetic and your static friction. Let's take a look at an actual example. A 10-kilogram block sits on a ramp that is inclined at a 30-degree angle to the horizontal. If the coefficient of static friction between the block and the ramp is 0.45, will the block slide? So the first thing we always want to do is draw a picture. So here we have our slope with our block on the slope. Now, of course, gravity is still going to pull straight down, but the component of that vector that is perpendicular to the surface is going to be this vector here. And so that's what will be the equal and opposite to the normal force. Now we have the other component of the vector, and that's going to be the component that is parallel to the surface. And that's what will interact with our frictional force, which will go against the motion. So the first thing that we have to do, of course, is find our normal force. We want to determine our static frictional force. Is it enough to hold that block in place? We already have mass, gravity. We know our ramp is at a 30-degree angle, so we simply plug in our numbers, and we find that we get 85.0 kilograms meters per second squared. So let's just move that over And now we're going to calculate our parallel portion of the gravitational vector, the part that's actually going to pull the block down the slope. So for this, we're going to use the sine of 30 degrees. So 10 kilograms gravity sine. And for that, we're going to find that we end up with a minus 49.05 kilograms meters per second squared. Okay, so now that we know how much force is pulling on the block, let's see if our static friction is enough to stop it. Here's our equation, and we know that the coefficient is 0.45, and we found the normal force, so we simply plug that in, and we find that our static frictional force is less than or equal to 38.3 kilograms meters per second squared. And since the static frictional force is less than that parallel force that's pulling down, we know that the block will slide. Now, if the coefficient of kinetic friction is given to us, this 0.33, we can calculate what the acceleration of the block is. Now we're going to look at our formula for our kinetic friction. Now we're going to use the same normal force, we just have a different coefficient to go with it. So we plug that in, and we find that our kinetic frictional force is 28.05 kilograms meters per second squared. Now we have to find out what is our net force on this box when it parallel to the surface. So we're going to add the two vectors together, the parallel component of the gravitational vector and the frictional vector. Once we add those together, we get a net force of minus 21.0 kilograms meters per second squared. So the box is still going to be moving down with a force of 21.0. So we can now use this to find out our acceleration, because we know that force equals mass times acceleration. And of course, if we divide out the mass, we're going to get the acceleration, and so we're going to get minus 2.1 meters per second squared. So the acceleration that this block is feeling on the way down is minus 21.1 meters per second squared, and it's minus simply because it's going down. Let's just move that over here. Let's say now that this block slides down the surface for 1.3 meters. How fast is it going when it hits the bottom of the slope? So we have this section of the incline that's 1.3 meters. It's going to slide across that, and we want to figure out what its velocity will be when it gets to the bottom. And of course, we have placed the block on the incline. So the moment that we let go is the beginning of the slide, so it starts with zero velocity. So we can use this equation here. And like I said, we know the initial velocity, we know the acceleration, we know the delta x. So we can just solve for our final velocity. And once we plug our values in, we're going to get 2.34 meters per second. So that is the speed that the block has when it hits the bottom of the incline, right when it's about to hit the floor. Now, let's just say the block is going to keep going when it gets to the floor. And let's say that the coefficient of friction between the block and the floor is 0.25. How far do we think this block will go before it comes to a rest? Now we're looking for a delta x. And we know that the initial velocity, because we just figured out what that was at the bottom of the slope, so it's going to be 2.34 meters per second. Now, the final velocity is going to be 0 because we are looking for the point where it stops moving. When it comes to acceleration from like gravity, that's not in play anymore on the horizontal surface. And of course, our kinetic friction is just going to be this formula here. So the first thing we need to do is find our normal force. So now we're on a horizontal surface, so there is no theta, or theta is 0, so that's just going to disappear. So our normal force is just going to be the 10 kilograms times gravity, which gives us 98.1 kilograms meters per second squared. So now that we have that, we can calculate our kinetic frictional force. Using the coefficient that they gave us, we are going to find that the kinetic frictional force is 24.5 kilograms meters per second squared. Now we want to find out the acceleration, more specifically the deceleration of this block from the frictional force. What's going to make it come to a stop? So just as before, we can simply divide out the mass to get the acceleration. So the acceleration is going to be 2.45 meters per second squared. And because that acceleration for friction is always going to go in the opposite direction that the block is traveling, we have a positive value. So now that we know that, we can use that same equation to calculate this delta x, because now we have both velocities and we have an acceleration. So if we rearrange this to solve for delta x and we plug all our values in, we're going to find that delta x is 1.12 meters. So each one of those steps was not that difficult, but you have to be careful because sometimes questions don't come to you this way. They don't walk you through it the way I just did, where I get you to find one thing and then I say, well, with this, let's find the next thing and the next thing. Sometimes you might have a question given to you directly like this, where they jump right ahead and ask you for how far the block will slide across the floor. And in this case, you have to recognize that you have to do all those other steps, and you needed to be able to tell yourself how to get through that. So that's one of the biggest tricks when it comes to these kind of questions, is making sure that you've done enough of them so that you can see the path from the beginning to the end in case the question just jumps right to the end. So I hope you found this video helpful, and if you did, go ahead and hit like. And if you want to see more videos like this, go ahead and hit subscribe. We'll definitely be looking at more forces coming up soon. See you in the next video.